Okay, so we're going to have a look at another high-level IB vectors question. Again, this is from section B, so it's quite a lengthy question. This is the first part, which is worth 14 marks. We've got points A, B, C, and we know that they lie on a plane. We've got to find the area of the triangle ABC, the shortest distance from C to the line AB, and also the Cartesian equation of the plane. Okay, so how do we do that? Well, first off, if we find the vectors from A to B, and we can just basically do point B take away point A. Well, point B, if we look at this notation here, that's going to be 1, 2, 3, take away, and vector A is 1, 1, 2. So therefore we have AB equals 0, 1, 1. And let's just label this as U1, U2 and U3. That'll help us in a minute. And also let's find out vector AC. And vector AC, well, we do vector C take away vector A. So we're going to do 3, 0, 1, take away 1, 1, 2. And again, if we do that, we should end up with 2, minus 1, minus 1. And let's label these ones as V1, V2 and V3. Okay, so we worked out the vector AB, we worked out the vector AC. The next thing that we need to do is find the cross product of these. So AB times by AC, when the times means the cross product. And for that we need to use the formula for the cross product, which hopefully you're already familiar with. You can always look that up in a textbook, but basically it's a combination of the U1s and the V1s and the U2s and the V2s. If we work out that cross product, we do end up with two lots of J, and also minus 2K. Okay, so in effect, if we want to write that in vector form, we're going to end up with 2, 0, 2, and negative 2 like that. Okay, so there we go. We've worked out the cross product of AB and AC. And then the last thing that we need to do is use the formula for the area of a triangle. So the area of a triangle is just going to be the absolute value of the cross product, and then times by a half. Okay, so this is the formula that we're going to use. Now the absolute value of this is basically going to be a half, and then we're going to do 2 squared plus negative 2 squared, and then square root all of that. And if we do that, then our final answer should be, if we work it out correctly, root 2. So there we go, that's the area of the triangle. Okay, so whenever we find the area of a triangle, so if we find the two vectors that enclose the triangle, then do the cross product, and then find the magnitude, and then times it by a half. So there we go, so the area of the triangle is root 2. Okay, the next part that we need to do is the shortest distance from C to the line AB. This one's actually a little bit complicated, or to actually work out what they're trying to do. It's sometimes useful if you actually draw a sketch. So here we go. This is A, this is B, and this is C. And basically they're saying the shortest distance from C to the line AB. So in effect, what we want is this here, where that is a perpendicular. Okay, and we want to find out like what this height is, don't we? So this is kind of the sketch that you would draw. Well, we already know the distance from A to B. The distance from A to B, if we go back here, from A to B was 0, 1, 1. So if you want to find the distance of AB, it's going to be the square root of 0 squared plus 1 squared plus 1 squared, which is equal to root 2. So we know that the distance from A to B is root 2. And we've also just worked out what the area of the triangle. We already know that the area of the triangle is also root 2. So we know the area is root 2, we know this length is root 2. Then we just use the formula for the area of a triangle, which is area equals base times height over 2. And in this case here we know that the area is root 2, and we know that the base is root 2, and we don't know what the height is, and we're dividing all that by 2, and therefore the height must be 2. Okay, that fits the equation. Okay, so that's part B. And then part 3, rather, the Cartesian equation of the plane that we've got here. Okay, so the Cartesian equation, if we flick back to here, we already worked out the cross product of AB and AC. Now the cross product of AB, AC already gives us the fundamental bit for working out this plane. So that's 0 to negative 2. Okay, and therefore if that's 0 to negative 2, then we already have 0x plus 2y minus 2z equals some number. Okay, so we've already got more or less sorted out already this. The only thing that we need to work out is what is this value d going to be. Well, if I look at this here, this is saying the point A is 1, 1, 2. Now if I basically put these values into this equation here, obviously there's no x's, I've got 2 lots of 1 plus minus 2 lots of 2 is equal to d, and therefore I end up with t equals negative 2, and that's it. So I now know that the equation of the plane Cartesian equation is 2y minus 2z is equal to negative 2. Okay, so looking at the second part of this question, so you get an extra 6 marks here, so a total of 20 marks for the question. The coordinates of the point D. Okay, so we've basically got a line L which passes through the origin, normal to the plane, and it intersects the plane at the point D. So let's have the equation of the line L. So the equation of the line L, well, it goes through the origin, so therefore it goes through the point 0, 0, 0. And if it's normal to the plane, well, again, coming back to the cross product, this cross product here, that is the normal to the plane, so that is what we've already worked out. So we can just simply write that as 0, 2, and negative 2 like that. Okay, so there we go, that's the equation of the line, and we want to find out when it intersects with the plane. Okay, and remember the equation of the plane that we've got is 2y minus 2z is equal to negative 2. And then we basically substitute these values in here into this. This is basically the x bit, this is the y bit, this is the z bit. So 0 plus lambda times 0, that's the x. 0 plus lambda times 2, that's the y. So let's put that in there. So that's going to be 2 lambda minus 2. And then the z is 0 plus lambda times minus 2. So that's minus 2 lambda equals negative 2. And if I solve that, I'm going to get lambda equals negative 1/4. Okay, now that I know that lambda is negative 1/4, I just put this into this value here. So the point of intersection between the line, if you think about what's happening, I've got a line and I've got the plane here. Okay, so if I put lambda equals negative 1/4 into this equation here, I'm going to find this point here where the line intersects with the plane. So if I put lambda equals negative 1/4 into this, I therefore get the point D, which is the intersection, which will be 0 minus 1/2 and 1/2. Now be careful here, it says coordinates, so I need to write it in this form here. I can't write it as a vector, I will lose marks if I do that. So the coordinate, I need to basically put this in here and then convert this just simply by writing it in that form rather than a vector form. Okay, so there we go, that's D. And then the last thing, it's asking me for the distance of the plane from the origin. Well, the distance, remember this line has gone through the origin. So if I simply work out, first off, if I work out the vector OD, well, the vector OD is 0, 0, 0 plus some kind of lambda, lots of, and this is here 0 minus a half. Okay, so that's the line that goes from O to D, and the distance, therefore, is the distance of OD. And I do the same as before, where I do, so obviously 0 squared plus negative a half squared plus a half squared. And if I work out that, I end up with 1 over root 2. So there we go, that is the distance of the plane from the origin.